but we start with just the root domain. From there, we will analyze that domain and see, are there any other domains that are associated with that root domain? So if you may have a .com, but maybe you also registered a .net, a .org, or something along those lines. So we'll find all of those, all right? And this is called scope expansion. And then what we'll do is we build all those domains, and then we analyze all of them for assets. Now, there's a couple of different ways you could do this.
Hello, everybody. Welcome to how attack surface management drives CTEM strategies. This is really a demonstration of the FortifyData platform's attack surface management and vulnerability management capabilities, which is a foundational component to anybody pursuing continuous threat exposure management strategy. My name is Marshall England with FortifyData. I'll be your host and moderator. And really quickly, for those unfamiliar with FortifyData, we are an automated cyber GRC platform with a lot of different capabilities, particularly this attack surface management one that we'll be showcasing today. We've done previous demonstrations on our third-party risk management capability, and we'll do some forthcoming ones around risk and compliance, so you can manage your full GRC process. But if nothing else, I'll turn it over to my co-host Eric, who will conduct the demonstration about our attack surface management.
All right. Thank you, Marshall. Well, just a quick introduction. My name is Eric Smith. I head up the Technical Services and Delivery Department here at FortifyData. I've been with the company for roughly 6 years. I've put a lot of effort into helping build the platform. My background is in cybersecurity. I'm a CISP, and I've been a former IT director and CISO in my past lives. I'm trying to bring all of the hard-won experience and knowledge that I've learned from that, and a lot of the problems that most people face into the platform to try and find better ways to give you the information you need and solve the problems that you have. So let's start off at the top by describing, well, what is attack surface management? And what is CTEM, in case you're unfamiliar with the acronym? It's Continuous Threat Exposure Management. So what are the underpinnings of this? Well, the first thing you've got to do is you have to understand what your attack surface is, because it may not be what you think it is. There are always things like shadow IT, there's legacy systems, there's relationships that you may be unaware of that are buried deep down. So understanding what your attack surface is first. And that's foundational, because if you can't get your attack surface right, then any analysis that follows is necessarily flawed. Meaning that if your attack surface analysis misses assets that are actually in your attack surface, well, that's a blind spot for you. The other side of that is if the attack surface analysis finds things that don't belong in your attack surface, then you could waste a lot of time chasing down stuff that isn't yours, you can't remediate, and it's making you look bad in the meantime. So we go to avoid both of these things. So let's start with how we do our attack surface detection in the first place. It's pretty simple, actually, in concept. It's just a very difficult execution. So what we do is we start with a root domain for any given company. This would be the root domain for your company or for a third party, because we also do the same type of analysis for third-party risk management. The methodology is no different. But we start with just the root domain. From there, we will analyze that domain and see, are there any other domains that are associated with that root domain? So if you may have a .com, but maybe you also registered a .net, a .org, or something along those lines. So we'll find all of those, all right? And this is called scope expansion. And then what we'll do is we build all those domains, and then we analyze all of them for assets. Now, there's a couple of different ways you could do this. And one way is quick and easy, but yields less than optimal results. And the other way is a little bit more difficult, but yields much, much better results. The bad way is doing this by IP block. You can go to things like ARIN or APIC and so forth and say, okay, find me any IP block that belongs to the company with name X. Let's just call it Acme Corp, okay? If you've ever used resources like ARIN or APIC to try and track down who owns a particular IP address, you know that's a very hit or miss strategy. Lots of times you're going to find that it's owned by an ISP, which then that doesn't tell you anything useful. Or you may find that, oh, it says it's owned by some corp here, but the record's out of date, or just flat out incorrect. So it's not a very reliable method for doing attack surface detection in the first place, which is unfortunate because that's what a lot of competing security ratings firms use to do attack surface analysis. And the side effect of this is it typically finds a bunch of stuff that isn't in your attack surface, but is attributed to you. And that's a problem. And that's another reason why threat actors don't use that when they're trying to figure out what your attack surface is. They use a DNS-based method, which is what we use. And what we do instead is we'll take that domain name and any of the other domains associated with you, and then we go start doing searches through various sources to seed that and say, okay, well, what kind of FQDNs have been historically associated with these domains? And from there, we can build a pretty doggone comprehensive list of everything that's in your attack surface. Because we're going back through years of history of anything that's ever been queried on for that domain in any DNS anywhere. But we don't stop there. The next thing we do is we take that list of FQDNs we've gotten, and then we start crawling all of them to see, well, what did they link to? Where did they go? And from there, we can build a very complex and comprehensive view of every FQDN that's associated with you. And then we can also do, we can build and guess what your subnets are based on what everything resolves to. So taken as a whole, this is a very, very comprehensive way of figuring out what your entire attack surface is. And more to the point, it's exactly what a threat actor is going to find because they use identical tools and identical methods. We routinely find a lot of stuff that people did not know they had, either active assets that have just been flying under the radar for months or in some cases years, legacy systems that have been left up when they thought that they were turned down, even stuff that is kind of still there but not really, like stale DNS records. You've still got entries for this stuff. It doesn't terminate on anything, but it does signal that you need to clean up your DNS because you've got a bunch of stale stuff in there. But it's a very comprehensive list, and this is done continuously. This isn't a one and done. So we are always looking for new assets, and the system is largely self-maintaining. We'll find new stuff as you bring it up. As you decommission old things, we will automatically figure that out. Like if you decommission a DNS record, it will no longer resolve. The system automatically figures that out and prunes that asset from your inventory. Same thing if you've got an unresponsive asset. You left the DNS record in place, but you turned off the server behind it. We'll figure that out too. So again, you don't have to deal with a lot of inventory management here. We find everything that's there, and we don't find stuff that isn't there. All right. So now we've done a nice job of external asset inventory management. What's next? Well, the next thing is figuring out what is attackable on these things. So now we pivot to what's essentially vulnerability management. We go and we say, we're going to scan all these assets. And when I say we're scanning them, I really mean it. It's not in the sense of like a port scan where we're just going to say, oh, you got 80 and 443 open. No, we're going to scan all ports, TCP and UDP on every FQDN, all 65,535 ports, everything that's there. So if there's a service there, we're going to find it. And let's assume we do pull back and say it's 80 and 443. We're not going to assume those are web servers either. They're just ports as far as we're concerned until we fingerprint them. So now we found that, let's say 80 and 443 are open. We're going to see, well, what's running behind these? Is it a web server? Okay. Yeah, it is a web server. What kind of web server? Is it Apache? Is it IIS? Is it Nginx? What is this thing? How is it configured? What information will it give up about itself if properly probed? We can get stuff like patching cadences off of this. We can get minor patch revision numbers. We can check for misconfigurations, information disclosures, security weaknesses, all of the above. And we do. We perform up to 160,000 potential checks on every port, on every service, on every IP, on every FQDN, on every domain that you have. And we do it all the time. Now, if this sounds very much like a pen test, well, it very much is the first phase of a pen test, which is the discovery phase. And we're doing that. And we're doing it the most comprehensive way that can be done. So now we've mapped out everything that you've got, all the ports, all the services, all the inventory, and we've done vulnerability analysis. So now we can surface this data. And we can see, hey, look at all these vulnerabilities that are present. In addition to, we also automatically identify your technology stack. So we would identify things like this right here. Well, you can see this is hosted with GoDaddy and it's making use of Google Workspace. Or you could go take a look at this one, which is a little bit more extensive. They've got plugins for Microsoft Advertising, Google Analytics, PHP. You get the idea. It's a very thorough analysis of the entire technology stack that's present on a per asset basis. All right. And all this feeds into other modules as well. For example, we can use this data to automatically detect that you have certain third-party relationships. If we see that you're hosting with GoDaddy, we know you have a third-party relationship with GoDaddy. And we'll automatically populate that on your third-party risk management if you use that module. Or if we see that you're using Imperva, for example, as a web application firewall, we'll correctly identify that as a security control. And that will go over into the risk and compliance module where we have a controls library. So again, we're leveraging all this data and connecting the dots in the most logical manner possible. Now, what I've just described is very much straight up vulnerability management. You scan things, you find your vulnerabilities, and of course, you can dig into these vulnerabilities and get more detail. For example, here you've got a PHP vulnerability with a remote code exploit. You can see we go all the way down to the port, the protocol, and the asset that's involved for every finding that we have. We also provide you with the evidence data points of why we flag this, because if we're going to flag a vulnerability, we're going to show you the actual sensor data that caused us to flag it. This and this, the vulnerability ports, the details, and the evidence are crucial in helping you make sure that you can easily localize where this vulnerability is. So you're not spending a lot of time trying to find it and figure out what service is this. And then we're also going to provide you with the CVE data and off-platform reference documentation that most of the time, this tells you exactly what you need to do to fix the problem. So again, we're trying to close that loop, the loop of detection of assets, awareness of vulnerabilities, the severity of the vulnerability, and closing that loop with remediation. And then even on the remediation side of things, you don't have to do anything on our side for us to notice it. Because remember, this is a continuous monitoring product. So when you fix something, you don't come in the platform and click a button and say, I fixed this, you can remove it now. First off, we're treating this like an audit. What we do is we are continuously testing your assets, not just for new vulnerabilities, but to see if you fixed any of the existing ones. So when you fix something, we are automatically going to note it as such. It'll be removed from your list of active vulnerabilities. And then that feeds back into the patching cadence module, because now we can begin to derive, well, how often do you patch? And how long does a vulnerability hang out before it's taken care of? And again, you get that data on yourself and on third parties. Also, we're not just doing vulnerability management here. We're doing risk management. That's the core of what makes this a GRC product, because you don't need to necessarily manage vulnerabilities, you need to manage risk. The main problem that people face in our industry is you're always going to have more vulnerabilities to fix than you probably get time and manpower to address, which means you need to end up prioritizing what you do to make sure that the remediations that you're working so hard to do are having the maximum beneficial impact on the company. Well, how do you prioritize? Well, I'll tell you how people have traditionally done it. Traditionally, you'll scan yourself, you'll generate some 300-page list of vulnerabilities, you'll sort by CVSS severity score, and whatever's at the top of the list, that's what you attack first. And you work your way down. You fix all the 10s and the 9s and the 8s, and then usually by the time you get into the 7s and the 6s, you're running out of steam, and you never really get to the 5s, the 4s, and the 3s. Okay? That's traditionally how it's done. But you can see the problem with that. Not all vulnerabilities are created equal, regardless of what the CVSS score says. For example, which is more threatening to your organization? A CVSS 6, I'm sorry, a CVSS 10 on an asset that has little or no business impact if it were to be compromised, or a CVSS 6, but it's on the most critical asset in your entire company with the most sensitive data that there is? Well, now you see the problem. If you're attacking based strictly on CVSS score, you end up, you might not get to that 6. You need to know not just what the impact is from a severity perspective, but what is the asset classification? How important is it to your organization? Well, that's a metric we include. So you can define the characteristics of your assets that drive the classification. And then then that feeds into the algorithm almost like a multiplier. So more critical assets get elevated priority in the prioritization engine over less critical assets, all other things being equal. So it doesn't mean that a 10 will always outweigh, I'm sorry, a 6 could always outweigh a 10, but it might based on the situation. And you can see how that helps refine the prioritization engine. But there's also much more going on than just, well, how bad is the vulnerability and how critical is the asset? There's also likelihood. And that's where our risk data truly shines because we are mining basically every data point out there that can be used to predict likelihood. And that is, for example, we know what threat actors are currently doing in their ransomware campaigns. What CVEs are they utilizing? Right? Not 6 months ago, today. Okay. And we update this data on a daily basis. So if you happen to have a vulnerability that is under active exploitation by a ransomware campaign, for example, then we're going to note that, and that automatically elevates the likelihood. Same thing goes if there's an exploit kit available. If this thing is something that a script kiddie can do a one click on, you need to know that. And if it is, and an exploit kit is available, again, the likelihood goes up a little bit more. We're also checking various sources like the CISA KEV list to see, hey, do you have, maybe it's not in a ransomware campaign, but it's being actively exploited in the wild right now. If that's the case and you have it, the vulnerability keeps going up. All these things are cumulative. We're also doing a vulnerability chain analysis. Maybe you've got a vulnerability out there that by itself looks fairly benign, but it's only benign unless certain other conditions are met. And then if they are, well, it's not really benign anymore, is it? Well, we're doing an analysis to see if that chain exists. And if it does, we will identify it, all the pieces in the chain, and then elevate the risk for every single one of them. So you know, hey, this isn't something I can ignore like the raw CVSS score might indicate. We're also checking for other ports and services running on these assets that could be contributory to this. We're also checking open thread exchanges, things like Alien Vault and other open thread exchange sources to see if the FQDN or the IP address has been spotted doing things it shouldn't be doing. Like, let's say, scanning other people, spamming other people, talking to a botnet command and control server. These are things well-behaved assets should not do. If they're caught doing that, that's a pretty good indicator this FQDN has already been compromised. Then we're also checking to see what threat actors, groups out there, might be targeting your specific industry. Let's say you're a hospital. Let's say you're a university or a bank. There are threat actor groups that target specific industries. And the more of them there are targeting your industry, the greater your likelihood. So again, that goes into the likelihood. And then last but certainly not least in the cumulative likelihood increasers is the targeted region. We geolocate all of your assets. If they're in a region that's under active exploitation, then again, likelihood goes up. So you can see all these factors go into predicting just how likely it is that someone's going to try an attack and what the success rate might be. It's as close as you can get to a crystal ball. Now, there's also things you can do to mitigate. You could have, for example, some preventative controls in place. Remember I said earlier, maybe you've got a web application firewall. So you can actually attest that you have these controls in place. And you would define their effectiveness and their scopes and things of that nature. And then we know what to apply this to. And then that can bring down your likelihood based on the effectiveness of it. This also feeds back into the controls library. So you're continuously documenting what your controls are. So you have a centralized controls library. All right. So all this data, you can see how it feeds into the risk model. So we can predict the risk of any vulnerability on any asset at any time and track it continuously. Now, the last phase of this, of course, would be the remediation phase. You've got to fix stuff. What do you target first? Well, we helpfully give you a list. It's called your prioritized risk list. What we do is we take the top 10 to 20-ish risks that you have, and we sort them by risk level, with the most critical risks always being on top and the decreasing severity as you move down the list. This is meant to be a generalized guide. So as long as you're working on something that's at or near the top of the list, you will always be working on things that are having the most beneficial impact to your cybersecurity for your organization. It's that simple. And you can come in here and you could say, okay, yeah, well, the business email compromise, let's say for phishing, let's say I can't work on that right now. There's something stopping me. All right, well, then I'll work on the network traffic notification, man, in the middle attacks. What is that? Well, you just click on it. We take you directly to the appropriate module. We automatically filter and say, it's these. This is what you need to be concerned about. Here's the asset. Here's the vulnerability. Here's when we detected it. Here's how long it's been hanging out unremediated. And again, you can drill into all of this information to whatever level of detail you need in order to discover what needs to be done. You can even create tasks directly in our module and say, I'm going to assign this task to Joe for remediation and so forth, and then track the prosecution of that task. Okay. Now, everything I've mentioned to you so far has been focused on external vulnerabilities. That's not all we do. We can also gather data on internal assets as well. So we do this with the aid of sensors. Now, we don't roll our own sensor. There's no point in that. There are plenty of good commercial sensors already out there, and most of our clientele already uses one of them. Think of things like a Nessus Pro or Defender or CrowdStrike or Rapid7 or Qualys or Tanium and so forth. We integrate with those sensors and use them to gather the raw vulnerability data, which is what they're good at. But then we put it through our risk analysis engine so that now you can say, well, this particular vulnerability, it's internal, but it's at elevated risk because of these additional factors and so forth. So now you're getting the full picture on your attack surface, internal and external. We also have a cloud security posture module. I won't be showing that today because that's a subject unto itself. But you can feed all of that risk data into one thing. And again, we're prioritizing all of this for you, external, internal, and cloud. Very simple. So you always know what you need to do. We have a dedicated risk and compliance module where we have all the standardized frameworks that you're likely to need, both the free and the premium ones that are licensed and so forth. But I also mentioned your controls library. This is, again, a very effective centralized place to go that we're constantly updating based on both your input and the detected stuff that we found. You can see right here for this demo company, well, we detected you're using Okta for your MFA. Well, then Okta's a control. So we automatically put it in here, and we've automatically associated with the selected frameworks, in this case, the NIST 853. Same thing as we detected that you're using Microsoft Azure, and you're using their WAF that comes with Azure, for example. So now we know this. If you were using CloudFront on AWS, you'd see AWS here. You get the idea. So again, all this data is in here. It's kept continuously updated. And of course, you can drill into it and get more data about it. You can actually define scopes and say, well, this particular control only applies to these assets over here. When you do that, again, that data is reflected back on the attack surface analysis. So it's all tied together. So I'm going to pause here for just a minute and give anybody a chance to ask any questions that they have. I
Sure.
don't get
Yeah,
opportunity
Eric.
to actually see it. Go ahead. Go ahead.
Yeah, I was going to say we do have a couple of questions in regards to back to the attack surface management as part of this threat exposure management strategy. Somebody wanted to know, what kind of quick wins could an organization do, or what would you recommend for some quick wins for an organization in the first kind of 6 to 12 weeks?
Okay, good. That's a good question because we have a lot of hard data on what works and what doesn't work. Okay. The easy quick wins are to use the prioritized risk list. This is going to go and tell you all the big stuff that you can hit out first. It may not necessarily be low-hanging fruit because some of the stuff might be difficult to fix, but you can quickly identify that here. You can say, well, I can't fix this, and I have to wait on Joe to fix that, but this I can address right now. So go and take care of that when you can. The other way you can do it is you can just come straight into your inventory. You can see that not only do we provide a score for your entire organization, and we track that score over time and allow you to benchmark yourself against an industry baseline, but we also provide individual scores for individual assets. This easily lets you identify the black sheep in your inventory. You can say, these are my low performers. So you could, if you wanted to, start at this list instead of the prioritized risk list and start attacking your low performing assets first. It just all depends on what you identify as the things that you know you can get to quickly and cleanly and knock those out first. And then you can actually set up longer term projects for things that say, well, this I can fix in a week or two, but this is going to take 3 months. Okay, well, go ahead and build a task around the 3 month item, even if it's going to take 3 months. That way you can start chipping away at it. But you'll be able to see the results on this as you remediate. So not only will we continually monitor things, but if you did a remediation and you want to know right now whether or not that remediation has any meaningful effect, you actually trigger a rescan of that asset right then and there. We'll get you very quick results and you'll know the effectiveness right then and there.
Eric, I've got another question, kind of on this similar vein in relation to inventory. For somebody who might not feel confident they're capturing all their assets or looking for shadow IT concerns, what do you recommend they do? And I can certainly shamelessly plug the fact that we'll do a complimentary assessment.
Yeah.
But in
Yeah.
regards to anything else, like what do you recommend people do to try and get a handle on shadow IT or looking for unknown assets?
Well, I'll give you the short answer. Use FortifyData because we're very, very good at this. Okay. You can imagine that if you're doing an in-depth comprehensive search across any FQDN that belongs to any domain that belongs to you, and at the same time identifying your subnets and scanning all of those for anything anywhere, even if it doesn't have an FQDN associated with it, um, it's going to be kind of impossible to miss anything. Like I said, it's anecdotal, but I could give, if we want to really get into it, I could give some real hard data on this. But we routinely find somebody comes to us and they're like, oh yeah, we've got an attack surface. It's about 600 or 700 assets. And maybe even they've got an exact number. Heck, they've even give us an inventory list and say, this is what should be there. And then we do our analysis and come back and we find several things that are not on their list. And what a lot of people do is they'll respond with disbelief. No, no, that can't be right. That can't be right. Let's go and look. Oh, it is right. That I won't say it's constant because some people have pretty good hygiene on this and some don't. But it is common enough that we find things that people didn't know that they had. And it's not just at the beginning. So as customers keep using the service over time, if somebody in a regional office decides to stand up some new server or service, unbeknownst to, say, centralized IT, we have a service in here that will detect that change in your attack surface in a maximum of 4 hours. It can't go unfound. So, yeah, we're keeping a very, very close, and we'll alert you. This service will go through here and every 4 hours it does an analysis and says, hey, has their attack surface changed? Is anything new there? Not just a new FQDN, not just a new IP, but a new port all the way down to that level, a new service. If your attack surface has expanded in any way whatsoever, you'll get a notification. And then you can say, oh, well, that was expected. I knew they were going to bring this up and so forth. But if not, well, you have a very small window where that's going to go unnoticed, and then it will be found and you will know about it.
Good points. I'll just reiterate again, if anybody's interested in a second or third set of eyes, again, happy to extend the complimentary assessment on the external services side. Another follow-up question in regards to hybrid environments. How can you ensure visibility across hybrid environments without deploying agents everywhere? And I think maybe you touched on it a bit with the agentless component around internal.
Well, it depends on how you want to define hybrid. Now, you could say, well, my hybrid means I've got some of my on-prem assets and I've got cloud. And then some people, that's obviously the typical definition of hybrid. But are your cloud assets internal only, or are they external only, or are they internal and external? Really, you don't want to think about it as hybrid of cloud versus on-prem. You want to think about it strictly on terms of internal versus external. Because if it's public facing, we don't care if it's in the cloud or on-prem or in a colo. It doesn't matter where it is. We're going to find it and we're going to assess it. It's public facing. On the internal side of things, we have a sensor or sensors because we support multiple sensor packages even concurrently. You could have Defender monitoring all your cloud stuff on the inside and a Nessus Pro on-prem for your regional office. Doesn't matter to us. We'll pull in data from both sensors simultaneously, combine the two data sets, deduplicate, normalize, and then show all the data in one place. That, by the way, is a party trick I'm unaware of anybody else being able to do.
Sure. Very good. This one kind of from the compliance framework or sorry, frame of mind. How can the ASM findings get links to existing GRC frameworks or risk registers for compliance reporting or continuous monitoring and continuous governance?
Well, it's good you brought up risk register because I was about to forget about that. But yes, we have a risk register in here. And the way the risk register works is anytime we spot a new risk, it gets an automated entry on the vulnerability-based risks. But you've also got your control and compliance-based risks. Now, some of this is going to trend into what we're going to cover in a future call about what is dedicated to the risk and compliance module. But once you assign and say, I want to apply NIST 853 or High Trust or SIG Light or heck that, it doesn't matter. You assign it. We know what all those control requirements are. Now, what we'll do is we'll take those control requirements and we'll take all the data we have on you and we'll try to answer as many questions as we can already automatically based on what the assessment data already shows. So that right there is super useful in two ways. One, it'll wipe out a bunch of questions that we already know the answers to. Two, since it's basing its answers on actual data of real assessment data, you may find you thought you were compliant and you're not, which is a very common thing. Lots of people have really nice, well-written, comprehensive policy documents that they're not following. And they may think they're following them, but they're not. We see about 70% of the organizations that we have who have very good, strong policy documents, they're not in compliance with their own policy documents, to say nothing of the actual compliance requirements themselves. So yes, it all ties in back to that. And you can go in and look at each one of your risks. And it's not just, again, not just control and compliance risk, it's third-party risks. You can build your own exceptions list. You can even create custom risk scenarios. So you're not tied to any of the risks. You can have any risk in here you want to identify as a risk, not just a technology-based risk. You could say, do you do background checks on new employees? That's a risk. You can, and you want to say, I have a control for that. You can document it in here and cover everything about the entire soup to nuts about the risks. This is all standard formalized risk management subsystem built into here. So hopefully that answers the question.
Yeah, no, really good. And I think this dovetails into the next one. I've got two more questions here before we conclude. This one is about, as part of a continuous threat exposure management strategy, right? Mobilization of remediation is kind of a critical area, right? You've got your foundational element of what are all my assets, what are the prioritized risks? How do I mobilize the team? Certainly, larger organizations might have a separate GRC, they might have a separate ticketing system. How can this help support those existing workflows?
Well, you did. I mentioned earlier, you do have the ability to assign tasks.
Yep.
You can come in here. You can actually, make people specific owners of assets and things of that nature. Of course, you can tag and put notes in on everything as well. But you can, outside of the task management side, and you don't have to use our task management. If you've got something like a ServiceNow or a Jira, you want to integrate with that, we can do that. And some of it's turnkey, some of it's not. Depends on level of customization and things like that. Then there's now, but you did touch on something of how do I motivate the team? How do I get them going? I want to point out something that isn't immediately obvious here, but it can prove a motivating factor. If you're in an organization that has lots of internal departments, think of like a university, for example, where you've got various schools, like a school of engineering and a school of medicine and this, that, and the other. You can actually group your assets together based on whatever criteria you want, subnets, VLANs, functional usage, geographic location, doesn't matter. Okay, you build it however you want it. But then we generate a group score, and you can kind of see where this is going. You can actually pit different departments against one another. So if you've got one department that is consistently causing lots of problems, and while the other guys are not, well, that makes them stand out in a way they probably wish they didn't. And that can give you some good leverage to motivate people to do things. Or even if they're not, you can certainly use it to take it to upper management and get them to apply pressure for people to do things. If, for example, those assets aren't under your direct control, as they might typically be in a university scenario. It also gives you deeper insight into things. You can say, if you're a hospital, well, the radiology group, they're never a problem, but over here, the neurosurgery group, well, they're always a problem. So maybe I need to focus on better user training or focus some kind of additional assets there to help make that not a thing anymore. And then track that performance increase, and you can see the effectiveness of what you're doing. Now, if you're talking strictly on a remediation standpoint, though, again, you've got all of the data you need here to understand what you have, how bad it is, and what you need to do to fix it, and then note automatically when it's fixed, and then capture all those metrics for reporting later. So yeah.
Yeah. Okay, last question, and this is kind of subjective, but I do recall when the original continuous threat exposure management research came out from Gartner, they made a prediction that those that had adopted these types of strategies would be 3 times less likely to suffer a cyber incident. And so this question is around how do you measure the success of a CTEM strategy? Given everything that goes into it. Obviously, everybody wants to avoid cyber incident, but are you looking at time to remediate, lower, improved scores, improved resilience, that kind of stuff? And again, I do think it's subjective depending on the starting point of the organization for sure.
Yeah. It'll be very subjective based on what the org values, but we do give you everything you need to figure that out, regardless of what your subjective metric is. For example, there is the score. Now, we're not a security ratings platform, and we don't even like to be compared to those guys. But we do generate a score, and it's an abstraction, but it's a useful abstraction because you can use it to track performance improvement over time. I can tell you, based on our historical precedents here, that we got a lot of orgs that when they first joined us, their scores were in the 300s and 400s range. They were pretty near the bottom of the scale. Within anywhere from 1 to 6 months, depends on how proactive the org is, okay? We'll see them in the 6, 7, sometimes 800 score range if they act on the data that we provide, okay? And that's a measurable way to do it. In fact, you can come into our reporting module and run an executive summary report and get this data very quickly and showing you here like total number of vulnerabilities. You want the bars go down. That's what you want. New vulnerabilities. You're not going to have any control over that. Remediations over time. You want bar to go up. So all this data is here at your fingertips at any time to know and be able to report on what's going on. Or maybe you want to say, nope, my metric is patching cadence. Okay, well, patch management right here. What's your min, max, and average time to patch across critical, moderate, low-level vulnerabilities? What is everything that's missing? When was the vulnerability announced? When was the patch released? How long has this been going on? That kind of stuff. So unless you've got some real off-the-wall metric I've never heard of, all the metrics you're likely to need in order to track your progress are here. Total number of vulnerabilities, time to close, score, you name it, it's here.
Perfect. That's the end of the questions. But yeah, thanks for your time today. Thanks for attending, Eric. Thank you so much for joining and giving the presentation.
You're very welcome. Thank you all for your time.